Get started. So, I already, most of you in here just kind of know what's going on. But you can feel free to read. So I'm gonna finish show method today. I want to try to give you an idea of maybe really the things you should be targeting for the final. I've actually been able to see it now. I wasn't for sure before. Wednesday, we're just going to continue to review. So might just be a day to ask questions, or I'll just come up with topic ideas. And then on Saturday, again, that's when the final's happening. It's from 10:30 a.m. to 12:30 p.m. and the lecture hall, room 100. If this is a conflict for anyone, I need you to let me know as soon as possible. So, and we can, there's other days that you can try to take it from this maybe in extenuating circumstance, or you have some really good reasons. Don't just change it because, well, I'm not going to be ready by Saturday, so let me move it. But yeah. So, we also we're going to do quiz 11, which is going to be a special little quiz for just so I can kind of help you a little bit. I am glad we're doing this because both disk and shell for sure are going to be on the final. Maybe not working all the way through, but at least knowing how to set them both up. And so we need to know how to do that. So please be working through those. I'll try to give you feedback on that as quick as possible. But yeah, so let's go ahead and we'll just talk more about shell method, and that'll kind of finish us off. That'll be the last topic for all the semester. Okay. Oh, it's pretty sad. We've come all this way and have come to the end. So some of you guys will be taking top 2, and I think some of you guys will be doing it with me still, but for those who are leaving, I hope you enjoy the time as much as possible. So, okay. So, and then, yeah, let me mention again, there should be course evaluations, so please finish those. And especially finish the one, I just really I'm going to be teaching during the summer again in the fall, so I want to know what works and what doesn't, so I can improve for later semesters. So I really read those, so please just consider. Okay, so back to it. So again, we're going to be talking about shell method, and I introduced this last time, but I'll go through and kind of explain the idea again, and so we can just reinforce it. So I have some object, right? I have some function. Maybe it'll look something like this, and I'm going to just take a section of it. So I'll just go from here. We'll let this be A, and we'll let this be B. And what we want to do is I want to find the volume of the shape that I get from taking this curve and just taking the whole thing and rotating it about the y-axis. Okay, at least in the x example. Of course, we can go the other direction, but I want to take this function, which is y equals f of x, and I want to rotate it about the y-axis. Okay, so the idea of how we start this is similar to how we started this method, in that I want to break it into pieces. So I'm going to take one piece, which is just going to be, some triangle, and I'm going to take that, or I say triangle, whatever. It's a rectangle. I'm going to take that rectangle and I'm going to spin it, kind of rotate it around just itself, right? And so when I do that, I'm just going to get some thin, really thin sort of cylindrical shape, something of this sort. So I get something that looks a little like that. Okay. Now, what we're going to do with this, right? How we're going to kind of take this and translate it to get the whole volume is I'm going to start by taking this guy, and I'm gonna approximate it by unwrapping it. Okay, so I'm gonna cut a little piece of it off, stretch it out, and I'm gonna get just like a rectangular shape. Right, so I just take a cut and I make it as much as possible to a rectangle, right? Now, this is gonna become pretty simple from here because to find the volume, because it's just a rectangle. But let's kind of talk about what each of these edges are, right? So here's my rectangle, right? Or yeah, the rectangle we're using. So let's again kind of draw the axis here so we can see where we're working from. And so I need to first ask what this distance is, right? So what the distance is from where I'm spinning around until I get to the outside of the shape, right? Or at least somewhere approximately to that, right? So what is this? You remember from last time, what is this distance? What do we label that distance as? Right, it's the radius of, it's what we're going to call our radius, right? In terms of the XY axis, so this is going to be just X, right? So I take some X value, right? Some X distance away from the Y axis, and that's going to be my radius in this case, right? So again, maybe I'll take this and look at it from a top-down view. Okay, so I have some radius, which is X, and that's going to go out somewhere in between here. Again, this is really small, so these edges are going to be extremely close to each other at this point. Okay, how do I find the circumference of this circle? It'd be whatever 2 pi r is, right? Which r in this case we're going to be using as X. So this length here, again, this is all approximately, right? Because technically we have two radiuses, but since this is supposed to be such a small thickness, we're going to act as the same. So this length ends up being 2 pi times X, right? Because the circumference was 2 pi X, so I just wrapped it. Okay. What's the height of this rectangle? It's going to be f of X, right? We're talking about the height of this little rectangle, which went up to the f of X curve. So the height here is going to be f of X. Okay. And then what's my thickness? What did we say that was? Yeah, it's kind of our delta X, or in this case, since we're doing more like infinitely, essentially, this is going to be dx. Okay, so for each individual rectangle, I am taking, to get the volume, I'm taking 2 pi X times f of X times dx, right? Because this is, call this length, this is height, and this is width, essentially. Length, width times height. That's the volume of a rectangle, or a rectangular prism, I guess is the appropriate term. So now what I do is if I want to get the entire volume, right? So that was just one section. So if I want to go through and get the whole thing, I just add up all of those individual ring shapes, right? And so that's where the integral comes in to say that we go from our left point, which is A, and our right point, which is B. And this, in general, is going to give me the volume of whatever the shape is that I want. Okay, now I'm gonna make sure, I'm kind of curious, I think the book, let's see. Okay. Yeah, so we're going to get into some examples. So here in this case, since we were just flipping around the y-axis, our radius was just going to be X, but we're going to be getting to some examples where that may not necessarily be the same radius, right? Because literally, right, if I'm going from the y-axis out somewhere, then whatever that distance is X, right? But I may not want to flip around the y-axis. Maybe instead I want to flip around this line, right? And so then my radius is going to change. So I'm going to address that in a bit, but for now we'll do a couple examples just to at least grasp the concept a little bit more. Okay. But the reason I mention this is because, and the book emphasizes this, do not put so much basic faith into this formula because it can vary, right? It's not always going to be the same thing, right? Sometimes you just have the function, sometimes it's in between two curves. The idea is to know how to set it up rather than how to, and just plug it into the formula, right? Okay, good. So let's talk about a couple examples. Any questions thus far to this point? Okay, good. So we're going to start off with, let's just say I have one. So I'm going to take function. So this is a function y equals x to the 2/3 power. And I want to find the volume that is obtained by taking this shape, right, from 0 to 8 and rotating it about the y-axis, okay? So in the end, I should be getting some sort of kind of weird funnel shape that's everything's kind of funneling into the center, but I want to find the volume of this thing, right? So we kind of follow the process over here. Don't necessarily need to draw your rectangle or anything. But we're going to use that to set up how to find the volume of this thing, right? So we start out, right? And in this case, I need to use shell method, right? Of course, the book tells us that. But also, one really good way to tell is that my function has been given in terms of x, right? And normally, when we were doing this method, when we were rotating about the x-axis, we were rotating about the x-axis. But now we're rotating about the y. Right? And because of that, since I have, right, and maybe this is good to kind of note this rectangle, since this rectangle is parallel to the axis I'm rotating about, really the idea I should be getting in my head is this. I'm not rotating it, I'm not just taking this rectangle and rotating it kind of perpendicularly, it's parallel, okay? So I'm using shell method, so we'll just address that now. Okay. Now to use shell, right? Again, first, my bounds are going to be really easy to write in this case because I know I'm going from 0 to 8. Okay. Now shell method always is going to have a 2π part on it, right? So that'll just be attached. That'll be always there. If there's one part that'll always be there, it's the 2π, right? And then the dx, of course. So maybe I'll go and throw that in the end, but that'll always be there. Okay. So if I'm rotating about the y-axis, right? I need to know what my, kind of the radius, the distance is from there. I need to know what the height is because I need those two things. So what is the radius in this case going to be? What is it? So what is it? It's not going to be x to the 2/3, and it's not going to be 8, right? Because I'm wanting everything in between here. If I just use 8, I'm only getting this side, right? But I want to work throughout the whole shape, right? So the radius is going to change. I don't just have one constant radius, right? Again, let's go back over here, right? Our radius in this case, right? I'm just saying, what's the distance from the y-axis to any point between A and B? Well, that's just going to be whatever the x distance is from there, right? So the radius in this case is going to be x. And so I use 2π x here. Okay, right? I'm just saying what's going to represent my distance from the y-axis there? Just whatever the x value is, right? So however far in the x direction I am, that's my radius. Right? So if I'm 2 away from the y-axis, then 2 is my radius, which is just whatever x is the height. Okay. Now, what is the height going to be at each case? X to the 2/3. Okay, so I'll write that here again. H is x to the 2/3 power. Okay, so radius is x and height is x to the 2/3. Okay, so This is my inner point, right? And then from here, you would go through and work this out. And so what's x times x to the 2/3 power? Yeah, you just take the exponents and add them up. So we take 1 plus 2/3, which gives us 5/3. And from there, that should just be a simple power rule there. Okay, but that's how we set that up. Okay, questions, comments, concerns on that? Yes.
So we're taking that whole shape, not just the rectangle, and moving it
Yeah.
around.
What is it?
Taking that whole shape, not just the rectangle, and turning it along the.
Yeah, so what I'm doing with the rectangle is I'm breaking up into pieces, right? Do you remember when we first did the integral, right? We did our approximations with rectangles, but ultimately we defined it using rectangles as well. I basically said, let me take this area, and I said, let me take this area and let me just break it up into rectangles. Right, so here's a rectangle, here's a rectangle, here's a rectangle, here's a rectangle, etc. Right? I'll stop here, right? And I use that to approximate, right? But the idea is that I can just keep making my rectangles smaller and smaller and smaller and fit them in, right? So, and then if I just go towards infinity and have an infinite number of rectangles essentially, right? That's going to approximate my area, right? We're using the same logic here. I'm saying take one rectangle, revolve that one rectangle around and see what that's doing. And then just add up all of them together, right? When you see what one individual slice is doing, right?
So we'll never have a defined radius then?
No, if you're going from A to B, then you should never have just a single radius, right?
It'll always be X,
Because your radius is always changing throughout the shape.
depending on what rectangle you want to use,
Um,
or where it's at, I guess.
Again, so the rectangle I put here is just kind of it's arbitrary. Like it's just I could have drawn it here, I could have drawn it here. It doesn't matter, right? It doesn't matter what rectangle you choose, right? Because no matter what, it would have just been X, right? I put it there just so like it's kind of in the middle, and so we can kind of have a place, but where the rectangle is position wise doesn't matter, right? Now I'll talk a little bit later to say that if the rectangle is horizontal and vertical, that might matter, depending on what the shape is, what we're doing. But where it's at doesn't matter because it's going to be the same. Okay.
Thanks.
Yeah. Any other questions on that? Okay. We will go with another example. Okay. So, and we'll just go ahead and jump to an example where we're going to have example 2, we're going to do the y direction now. So I'm going to have a line, and this line is, the line is going to be y equals 1/2 x, right? And they may just give you this, but I'll draw the picture of this so you can see it right now. So we're given that we want to obtain the region that's bounded by y equals 1/2 x, bounded by y equals 2. So let's see. 4. Okay. So this is y equals 2. And bounded by, and the y-axis. Okay, and I want to take this and rotate it. So this is the area I'm talking about. And it says that it wants me to take this and rotate it about the x-axis. But I have to use shells. Okay. So this is where we're going to really have to start thinking about what's the difference between disk and shells, right? Because maybe let's first talk about how I would do this problem if we were doing disk, right? Because this seems a bit more like a disk example at first, right? I have y equals 1/2 x, right? So again, similar to how the box was in that picture, what I should be visualizing is since I'm dependent on X, I'm gonna have a kind of a vertical rectangle because my height's gonna be dependent on the Y in this case for each piece, right? And so to get the volume obtained by rotating this around, right? Traditionally, we would think, okay, well, maybe this would be a disk problem, right? Which we can do this using disk, right? If I were to do this using disk or washer method, right? How would I do this, right? What would my so let's kind of talk through that real quick. So I want to get this region that's bounded by all these lines, right? And so the first step, of course, is to figure out, okay, well, what are my X bounds in this case, right? So here, yeah, let me have it right on the side. This is what disk would be. So if I want to figure out what my bounds are, right? Can anyone tell what my bounds are just from this picture? So one bound is 0, right? And the other bound is 4. Now the reason we know it's 4 is because we have where it's where y equals 2 and y equals 1/2 x are intersecting each other, right? That's where this point is. So we need to know when 1/2 x equals 2, right? That just comes from knowing, stuff of area between curves, etc. But that's going to give us x is 4, and so that's my upper bound. Okay, what would be the next step in sort of doing the disk method in this case? What do we think? Well, something I'd definitely be. Well, yeah. There'll be a dx at the end, right? You need a pi, right? So on shell method it's 2 pi, but on disk method we just need a pi. Okay. So now the object becomes, well, what's going in between there, right? So with this method or washer, I guess I'll put washer above because this will probably be a washer example, right? I have to figure out what's an outer radius is and what an inner radius is, right? So looking at this picture, right? Do I just have one radius to worry about or do I have a couple? I have 2. And the reason being is because I'm rotating around this axis and there's all this empty space. And so I need to take out that empty space, okay? So what is the big radius in this case? 2. So I'm going to put this in parentheses here. So the big radius is 2. So I do 2 squared, okay? What's the inside radius? It's going to be the 1/2 x. 1/2 x squared dx. Okay, so this would be disk method. Okay, this is how I would use disk method to get this area. Now so we want to, obviously we want to use shells, and if we use shells or disk, we should hopefully be getting the same answer, right? We're finding the same volume. So let's figure out what this number is going to be real quick. Okay, so this is going to be integral from 0 to 4. I'll bring the pi outside. So we're going to have 4 minus 1/4 x squared dx. Any arguments on that? Any disagreements? Is that good? We just square each one and subtract. Okay. What is the integral of 4? Okay, good. So we have 4x. And what's the integral of 1/4 x squared? Good. So we have 1/4 times x to the power of 3 over 3. So then I can just take that 4 and the 3 multiplied together, and we get 1/12. Then we're going from 0 to 4. 0 luckily just takes both of those away, so we don't have to worry about it. So we'll just plug in 4. So I'm going to get, let's see, pi 4 times 4 minus 112 times 4 to the 3rd power. Okay, so yeah, 16. So we get 64 over 12, which is 32/6, which is 16/3. So it looks like it should be 32 pi over 3 should be your answer. Let's see, okay, so this, so this is correct here. So doing this method, we get 32 pi over 3, right? The problem, didn't want this though, right? It wanted us to use shell. Okay? And because it wanted us to use shell, again, here's something we really need to pay attention to, right? We're gonna have to sometimes, like, so in these problems, especially the disk method section, it was just pretty clear, oh, I'm using disk, so if I'm rotating about this axis, I need everything in terms of X, but if I want to rotate about this axis, I need everything in terms of Y, okay? It's gonna get a little fuzzy here, which is why you need to think about what you're wanting and what would be the easiest thing to do, right? Usually whatever they give you, like what function they give you, is probably the more straightforward way to go, right? Unless they say use a specific method, then you might have to change it. Okay, so I'm gonna lay out a little table for you guys to help to know when to pick everything. Okay. So let me draw this. Okay. And this table can also go, backwards or forwards. It just relates things together here essentially. Okay. So let's say I'm going to split this into 2 boxes. In the top box, I'm going to have y equals some function of x. Okay, so y equals f of x of some sort. And then in this box down here, I'm going to do x is f of y. Okay, so one case it's y equals f of x, the other case it's x equals f of y. Okay, whenever I'm doing y equals f of x, that will actually does. Okay. I should be imagining that I have a vertical rectangle. Okay. And the reason being is because I'm using dx, right? So my width in each case is like infinitely small, right? And so the height, the y part gives me all the height. Okay. So the rectangle that I might want to imagine in my drawing, whatever I did, should be up or down. In the x equals f of y case, that's the opposite. We would want to do dy, right? So now all the thin part is in the vertical direction. So I need to stretch out the horizontal. Okay, and so I'm going to get, again, I just trying to save space, but your box should go this direction. Okay, and we're going to see that when we do shell here, but I want to go ahead and lay out the idea. Okay, so okay, from here, so if I have y equals f of x, and I want to go about the x-axis. We'll go ahead and throw this out. So, or maybe I'll black this way for now. Okay. If I have y equals a function of x, and I want to go about the x-axis, right? So that's kind of what I had in this example, right? What method did we just use? We used disk and washer, right? And that's going to be a general rule. If I'm given a function of x and I'm going about the x-axis, then I should be using disk and washer, right? So you can think about this a few ways. The first way is just saying, okay, x, f of x, and x, that lines up. I think the maybe easier way to see it is that since f of x I'm gonna represent by using a vertical rectangle, right? Notice that vertical rectangle is perpendicular to the axis you're going around. And because of that, since it's perpendicular, I have to use disk and washer, right? Now we were just talking about shell over here, right? So we had f of x when we were going about the y-axis, right? And the easiest thing here is to use shell. Okay. And again, that's because we have a vertical rectangle and we're going about the vertical axis, so they're parallel to each other. Okay, it's the difference between perpendicular and between being parallel. Okay, so maybe I'll even put on the side here, here's a little perpendicular, parallel. Okay. So now let's talk about the other case, right? So if x is a function of y, then we have a horizontal rectangle. Is a horizontal rectangle perpendicular or parallel to the x-axis? Parallel. So we're going to use shell. And since a horizontal rectangle is perpendicular to the y-axis, then I'm going to use this one. Okay, so this is really in a case where you're like, this can really go both ways. This kind of helps really to distinguish. In this case, we're going to need to use, we want to use shell, right? And so this might help us to decipher a little bit what we need. But this is a good place to go back to. Okay, so continuing on our example here, we're going to use shell method now, right? So if I want to use shells, right? We're still going about the x-axis, right? So if I'm going about the x-axis, it's either this guy or it's this guy, right? I can only use one of these two, right? Because obviously I'm not going about the y-axis, so I can't use that, okay? And if I have to use shell, that puts me in this row, right? So the way that I'm going to do this problem to do it using shell is I need to rewrite my function, right? Because here it's y equals f of x, which is what we did for this. But now I need to actually be a function of y, right? So how do I rewrite x as a function of y in this case? If y equals 1. Not y equals x, right? I need to solve this for x, right?
2y. I think you said 2y.
2-1.
X equals 2y. Okay, so I'm going to redraw this picture. And now we're going to kind of change everything a little bit. So we have the same bounds in general, right? So I still have y equals 2, and we have the y-axis. But now this is going to be, this line is going to be x equals 2y. Okay, and because it's x equals 2y, I'm going to be using a horizontal rectangle. Right? That just follows. If you're using function of x, you may go up and down. If you're going function of y, we need to go left or right. Okay. So now we're going to try to use shells on this, right? Because it asks us to use shell, we just have to change the functions right now, right? So to do shell, right? So now everything's happening since our dy is kind of here. Everything's happening in this direction. Right, that's how we're changing it. It's not left to right now, we're going up and down. Okay, so what are my bounds in this case going to be? 0 to 2. This one's actually a little bit clearer, right? Because we still start at 0 here, and I just go up to y equals 2. Okay, so that one's even a little bit easier. Okay. Okay, we have the 2 pi, of course, again, because we're doing shell. What is it? Yeah, so it's going to be y in this case, right? Now y isn't y. Yeah. Right, and we're rotating about the x-axis, right? So yeah, absolutely. I'm just how far am I from the x-axis, which is the y distance. So we get 2 pi y. Okay. And then I need the height of that rectangle. Just 2y. And then of course we need to do y. So now this becomes my integral. Okay, so let's evaluate it. This one actually is probably a little bit easier, I think, to do, right? So this is going to be 0 to 2. I'll go ahead. We'll take the 2 pi out. 2 pi 0 to 2 of 2y squared. I probably could just took it out. So we have 2 pi and then another 2, so I'll just take all that out, and that's gonna become 4 pi on the other side. And so we get the integral from 0 to 2 of y, y squared. What is the integral of y squared? Mm-hmm. Zero to 2. Okay. Again, 0 doesn't do anything in this case, which is great. What happens when I plug 2 in there? Right, so we're gonna get 2, yeah, so we get 8 over 3, right? Plug in 2, and then 4 times 8. Gives me 32. Okay, so it's exactly the same. So the same answer, okay? The only difference is in the method we used, right? So again, we'll definitely go through another example of sorts, right? But so this is really helpful if you just want a very systematic way to kind of go through it, and that's why I write that. A lot of my recitation students from last semester really enjoyed having something like that. But right, you just need to pay attention to if they ask for a certain method, right? You need to make sure that everything's lining up, right? So if I wanted to use shells, right? But I couldn't really use shells in this case if it was a function of x. And so I had to rewrite it before I used it, right? But when I did that, it actually became a lot easier of a problem. So even though it seemed like this would have been the better way to go, I think we can probably both agree that that's easier to write, easier to do, right? That took a lot less time than this is. And you don't have to worry about the 2 functions. Okay. This is important. So any like questions on this?
Where'd you get the bounds?
What is it?
How'd you get 2 and 0 for the bounds?
Okay, so we're working up and down, right? So what is the lowest part of my area?
0.
0, right?
Okay.
It's basically, and you can also think, okay, well, that's where x equals 2y and the y-axis hit each other, right? But that's just going to be 0, right? That's down here, right? If you draw it, you'll be able to see it. And then the top part of my area, right, stops at 2.
Okay.
I don't go past it.
It's because we're working with a horizontal rectangle this time.
Yes.
So we're using bounds up and down.
Yes.
Okay.
So horizontal rectangle means you do bounds up and down. Vertical rectangle means you do bounds left or right. Okay, so I would make really good use of those rectangles because they help you. You don't have to do all the excruciating work or really, like maybe kind of just use the integral basically, but that helps to guide you at least. Okay. Any other questions on that? Yes. Thank you. Yeah, so I'm definitely going to encourage you. So the questions in this section, at least many of the first few ask you to use shell, but then there's going to be a section that asks you to do both, and then there's one section that asks you to do the most convenient method. So, but this isn't really bad practice, like at all. Like this is very useful. Like it's good practice to be able to understand both of them, right? Because if you just take the minimal amount of effort to just say, okay, if they use disk, if they ask for disk, I'll just use disk, and they have to shell, I'm going to use shell. And then just use the formulas given, you could probably get the right answer on the final potentially, but you're going to go from this class into other things and not really understand what it's for. Okay, so and obviously knowing how to do the harder part makes the or basic part really simple. So okay, great. Okay. Next example. Any last questions here? Okay. So, for example 3, okay, we're gonna up the ante a little bit. We're gonna take 2 functions. One function is going to be x equals negative y squared plus 4y minus 2. And the other function is x equals y squared minus 4y plus 1. Okay, and I want to find the volume. So find volume obtained by rotating region so it's the region bounded by these two curves about the x-axis using shells. Okay, so we just need to use shells to do this problem. Okay, so we'll take some time real quick and maybe just actually, how should I get my bounds in this case? Yeah, so we're gonna be setting these two equal to each other, right? Because we want the area that's bounded between the two regions, right? So it's gonna be wherever they cross each other at, right? Those are gonna be your bounds, right? So I'm gonna take negative y squared plus 4y minus 2 and set it equal to y squared minus 4y plus 4. Okay, which let's see. What should be a next step here? Y squared to both sides, and we really need to move everything, right? So I'll go ahead, if I'm adding the y squared, I'll subtract this 4y, and I'll also add the 2. Okay. What am I left with when I do that? You get 0 on this side. What am I left with on the right side? Okay. We need to solve that. How do I solve it? Yeah, we can't really factor out a y. What is it? Pull out a 2. We'll start out by pulling out a 2. Okay, so 2 times y squared minus 4y plus 3 equals 0. Okay, can I do anything with this guy?
Y minus 3 minus y minus 1.
Okay, so then what are my two y values? Then y equals 3 and y equals 1. Okay, so those are going to be my two bounds. Okay. Okay, so let me, I'll use this space right here, and I'm gonna try to draw just a quick picture maybe of what this looks like. To the best of my ability. I know this one, this actually factors, anybody know what this factors into? Close. It's not, there's no y plus 2 though.
Is it y minus 2 squares?
Yeah, it's y minus 2 squared. And so what that is just a parabola that's moved to the right. So it'll look just like that. The other one, let's see, negative y. So we know that they cross each other at 3 and 1. So that might help at least 1 and 3 of that. Probably. So this is just going to be, maybe that's the best picture, but we'll get something like that. Okay, so we have these two curves. It may go down more, but this is the idea, right? This is what we're getting, and this is the region that's bounded between them. Okay. Now again, I'm drawing this just to emphasize what we need to do. You probably could figure out without having to draw like what the region is, but okay. So what? How should I draw my rectangle in this case? Horizontal, yeah. I mean, that's the most straightforward way, right? And also since it's shells, we're safe, right? Because it's parallel to the x-axis, and that's where we're going. So that's all good. Okay. So now let's just build this like we did, like we have been, okay? So we're going from 1 to 3, right? So this is my volume. What do I need first? 2 pi y, good. Yeah, so it's gonna be y again. And that's just because, again, we're going about the x-axis, right? If you're going about the y-axis and you're using shell, it should probably be x. And if you're going about the y-axis and you're using shell, then it should probably be y. Or, sorry, I think I had this flipped, but I think you get. Okay. X-axis should be y, y-axis should be x if you're using shell. Yeah,
The second parabola to the side from front.
here,
Yes.
this equation.
Oh, okay.
Why to the side and not down?
Well, it's x equals negative y squared,
Yes.
right? If you're thinking of y equals negative x squared, which would be like this,
Okay.
right? But x is negative y squared actually shoots to the left. Okay. How about my function in this case? Or my height, I guess, right? Because you said function here. I want to get the height of the rectangle, right? How do I get the height of this rectangle? Wait, what were you saying? So you're gonna use something like this. I think the signs may flip depending, I'm not sure, we'll check. But we need to go back to area between curves, right? Remember, if I'm finding the height, of kind of the section between the two curves, right? I need to see what the higher curve is and then subtract the lower curve, right? So in our case, what is the quote unquote higher curve?
Y squared.
Good. So we're gonna have negative y squared plus 4y minus 2. And what is the lower curve in this case? What?
Y squared minus 4y plus 4.
So I get this. Okay, and like Spencer was saying, this is gonna turn into something like this, but the signs will be flipped. And the reason why is because sometimes it may end up they be the same, but obviously it was easier to make this a positive 2y squared instead of negative, so we'll keep that in mind. Okay, but that's once we fix that, which again, 2 pi y. And that's gonna be negative 2y squared plus 8y minus 6. Again, you don't have to rely on these being the same, just still subtract and combine together. And then I can just multiply this y through and fix it from there. That would be my point. Okay? Yes,
How did you know the first one was the higher one when you subtract them?
this one?
Yeah.
So I'm gonna say higher, quote unquote. I'm just saying which one is so our standard in this case, right? Since we have x as a function of y is the y-axis, right? So to know which one's higher, I'm seeing which one's farther from the y-axis, right? In the region I'm talking about. When I looked at the region, right? Here's the y-axis, right? This curve is clearly farther out, which is the negative y squared. Yeah. Was it? Well, it might work sometimes, but I wouldn't guarantee that because sometimes it may, again, the sign may stay the same. It will always be flipped. It just happens to be flipped in this case, right? That's not a guarantee. So I would still do that just to make sure. I think that's safe. And I would rather see you subtract the two curves. Hey, any other questions there? Nope. Okay, if I gave you this, would you know how to evaluate that? Okay, just don't try to do U sub here. That'll make your life a little harder. Okay, just multiply the y out to each piece and then take out the 2, right? And then you're just gonna get negative 2y cubed plus 8y squared minus 6y, which is just a polynomial. Okay. One more thing one more thing to mention. And that is, now this didn't do this, which I was quite surprised about. Now I might, of course, in this section potentially depending. So I might talk about an example of this, but so here's the situation. So we're gonna find the volume. So it actually didn't say a method in this case either. So we'll have to figure that out. Okay, so example. So we want to find volume by rotating. Okay. So I'm maybe region bounded by y equals 2x. X is -1, no 1. And the greater than x. About the line x is -1. Okay. So things are going to get a little bit more interesting now. In that I'm not just flipping around the x or y axis, I'm flipping around another line. Okay. Because sometimes solids don't always just rotate about those axes as easy as much easier as it makes it. So how do I go about approaching this? Okay. So let's think about the region first. Okay. So what is y is 2x? Just a line. What's the slope of that line? 2. What's the y-intercept of that line? 0. Okay. So we go 1, 2, 1. This. Okay. And x equals 1 is horizontal, vertical. Vertical. Good. Okay, and the x-axis is here. Okay, and I'm rotating it. Right, maybe it was excuse some colors here. Oh wait, no, not here. That's -1 here. Okay, I'm taking this region and I'm rotating it around x equals -1. Okay. So the question becomes, how do I do this? Okay, so first, it doesn't say what method to use. If you had to guess what method to use here, what would you say? Whoever said shell is correct. We're gonna use shell, because again, if it doesn't say specifically, then you really have the freedom to do as you choose, right? But usually our first intuition should be to choose whatever the easiest is, right? And in this case, I have a function in terms of x, right? So I should have a vertical rectangle, okay? And so that vertical rectangle is parallel to the axis I'm flipping around, okay? On my table, I had x and y axis just as a basis, right? But in general, again, this still applies even if it's not the x or y axis, right? Since this is parallel to this blue line, I want to use shell method. Okay, so we just have to work to build whatever the shell method is in this case, right? Okay, what are my bounds going to be? It's not going to be 1 to -3 in this case. So remember the bounds that we use are the bounds of the region that we want, right? Where's the region at?
0 to 1.
0 to 1. So 0 to 1 are my bounds. Okay, so that doesn't change. Okay, what do I need next? 2 pi. Okay, what's the radius gonna be in this case? So so not x minus one, right? So what's gonna happen, right? Here's how to think about it, right? The radius usually would be x, right? So if I'm going from the y-axis to the rectangle, the distance is typically x, okay? But now I'm not just going from the y-axis, I'm going from x equals -1. So what did I just add to that x distance? Added 1 to it. So the radius in this case becomes x plus 1. Okay? Or the book kind of does it like this. It says x minus -1. Because what it's saying there essentially is it's saying typically that like we like to think the lines would be over here. And so if I'm getting a region, then I would say, okay, here's the x distance minus however far that line is from it, right? Or I don't know, I guess I prefer just to kind of think through it and look at the picture. And so I would encourage you to do the same because we can get extra x plus 1 from there. That would be it. Okay, so that is my radius. What's my height gonna be? It's just the height of my rectangle, so right? Okay, so the only real change that happened is the radius became x plus 1. Everything else remained the same. Okay, from there, just multiply and do the integral, and that should be smooth sailing. Okay, questions on that? That was pretty, not too bad, right? They seem a lot worse than they are, but it's really not too bad. Okay. Questions? Yes, no, maybe so. Okay. So that is the fix to make if we're doing shell, and maybe I'll just add in something extra, like an extra thing to think about. What if? So now let's consider what would happen if maybe instead of it being the blue line, let's say that I'm over here, and this is, so I want to take it and flip around x equals 2. Okay, so let's, what is it?
Measure from the center. Your radius is always measured from the center.
Right, so you start from the center, right? So this distance is going to be x, right? How far is this distance? This distance right here is 2. Okay. So if I'm wanting to know the distance from x equals 2 to that rectangle,
Plus
right?
1,
what is it?
just plus 1.
Not plus 1, not minus 1, right? Again, let's think about it, right? So my whole distance is 2, right? Not minus 2, not minus 1. Well, okay, listen, the whole distance is 2, right? The distance to the rectangle is x, right? But I don't want this distance to the rectangle. I want this distance to the rectangle, 2 minus x. So the radius in that case would be 2 minus x. Okay, that's why I don't really know why they would set it up like that. I think it's just confusing. I think it's just a lot easier to just really take the time and like think about it a little bit, right? Again, if it's just the x or y axis, it's just x or y, right? And that's just gonna be that's it's as straightforward as that. But if you're moving around something else, you really need to understand where am I coming from? What's the axis? What's going on, right? In this case, I knew this was the x distance I wanted to the rectangle, and then I just had an extra 1 distance I added to it. Here, I have that 2 is the total distance, but I want to take off whether this x distance is, because that tells me what this blue distance right here is supposed to be. And so that would be 2 minus. Okay, so I understand if you don't get it, if you won't get it right like 100% of the time all the time. That's okay. But we just need to be thinking. We need to get, get a total going on these things. Okay, so for our last example, we'll go back and do this method, maybe with going around a different axis. Okay, because of course, that one doesn't have a radius like that, and so we need to think about it a little bit. Okay, but any other questions on that front? Yes, no, maybe so. And again, if you're not sure, if it doesn't tell you which one to use, feel free to use the little table I made for you. Hopefully most of you wrote it down. It helps tremendously. Okay. So let's go up with 5, okay? And let's say, actually, I'm just gonna take the same example, okay? So we'll do, so we're gonna have the same region. So, so we have y equals 2x again, right? We have x equals 1, and we're bounded between the x-axis. This time, I'm gonna rotate. I want to find the volume by rotating this around the line y equals 2. Okay. So, again, so y equals 2, right? So now what's happening, maybe I'll use the red to point this out, right? Is I'm taking this region and I'm rotating it this way. So let's work on setting this up, okay? So how should I draw the rectangle in this case? I wouldn't do horizontal first. I mean, because then you'd have to change it in terms of x. You'd have to write x equals function of y, right? The most natural thing is to just do a vertical, right? So if I have y equals a function of x, I could choose a vertical rectangle, right? Okay. So if I'm using, if I'm using a vertical rectangle and it's perpendicular to the axis, what method should I use? Disk or washer, right? In this case, it's probably going to be washer because we have the space between. Okay. Okay. Good. So let's start with the center then, right? So we're using disk. What am I bound? We need a pi still, yes. It's the bounds are from 0 to 1. Right? That actually didn't change from here, right? It's still the same thing, right? I'm considering everything's in terms of x, right? So I just look at where my area is in terms of x. The left side is 0, the right side is 1. Okay. Okay. Now the radius is where this is, obviously the radius here is where it's going to get a little bit more interesting. Okay. So what is the outer radius going to be in this case? Right, because I need 2, right? We have an empty space. I need 2 of them. What is the outside radius going to be? So it's not x equals 1 or x equals 0, right? The thing is again, since we were going around the x or y axis, usually it would just be whatever the functions were themselves, right? But now we need to really think about what's my radius in this case. Yes, this line right here is y equals 0, right? It's not x equals 0. X equals 0 would be here. Y equals 0 is this line, right? But I can't, obviously the distance from here to here isn't 0, right? We want the distance from here to here. What is the distance from here to here? 2. So my outer radius in this case is 2, right? Because that's this distance. Okay. What is my inner radius going to be? Not 1, not 2x squared, right? Because again, what you're thinking of, right, is you're thinking of what this distance is, right? That's 2x, right? The height of that rectangle at that point is 2x. But I don't want 2. I don't want 2x. I want the distance from from here to here. So if this white height I just drew here is 2x, 2 minus 2x. So here's actually something pretty funny, right? It's to note that, I mean, it's literally just what happened is maybe if we were flipping around this axis, right, I would have 2x squared minus 0 squared, right? But now I've just put 2 under it, put 2 with everything. So you should probably see that pattern anytime you do something like this. Okay, so if you have like 2 here and you get like 47 over here, you might be skeptical that you might, see anything about it a little bit more. Okay, this is really a thinking game though. Okay, so I really, encourage you just to like sit and, if you need to stare at it for a while, feel free to think about it. But that's how we approach it. Okay, so again, you just kind of square things and evaluate it, and that's how we would do it. So that would.
It looks like a square to me, so it's like, why can't you just take half of that?
Oh, are you saying this region?
Yeah.
So what you might be, I'm not sure if I'm interpreting this correctly, but I think what you're suggesting is this whole thing forms a square, right? And that's really easy to rotate around. That's literally just a cylinder. I would get the same volume if I rotated about this way. And so the question is, if I just took half of that, would I get the same area? And the answer is no, probably not. We can check, right? I mean, of course, there's cases where that might happen. So this is going to be, so let's see, we're going to get 4 minus, what is that? 4 minus 2 times 2, 8x. Yes, so we get pi 0 to 1 of 8x minus 4x squared. 8x pi 0 to 1 of 4x. 4x squared minus 4/3 x cubed from 0 to 1. So we just get 4 minus 4/3, which is 12/3. Wait, no. That would be 4, 12. 12 minus 4 is 8. 8/3. So this is our answer, right? So the claim is that half of just taking a square and rotating it around, right? If I just took the square and rotated it, that would literally just be a cylinder with like a height of 1 and a radius of 2. Thank you. So it'd be pi 2 squared times 1, which is going to be, if I divide that by 2, I get 2 pi, which is not going to be 8 pi over 3. So it's slightly bigger, right? And it's all due to how you're rotating it, what things you're cutting out, what things you're keeping. So unfortunately, yeah, we can't. It's not. Now, if you're just talking about the area, then of course, yeah, you can just find the area of the rectangle here and then just divide by 2, right? Because it's evenly cut between the two. But when it comes to volume, it's not always the same. Okay. Cool. Questions? Other questions? Yes.
I thought for the washer method, you just square each function and then subtract it from each other.
Normally, but that's if we're rotating about the x or y axis.
Oh. that's
What axis are we? What are we rotating about in this case?
y equals 2.
Y equals 2. So it's different. Okay. That's why I don't want you guys to memorize the formulas. I want you to remember how to set them up. Right? There's a general idea. There's everything, like this is always going to need pi big R squared minus little r squared. And the other one's always going to need 2 pi r times h. right? But the question is, what's the R, what's the H, what's et cetera, right? Because it's not always gonna be the same. Okay. So, of course, like obviously, if you're, working through the book and you get to the easy examples where it is just X or Y, then those formulas come in handy. But if it comes to anything else, you might need to be skeptical. Okay, yes.
Would you say that final is easier than the test?
Okay, I'm gonna talk about the final here in a bit. Is everybody good here?
Yeah.
Okay, I'll go ahead and talk about the final a little bit then. So as I mentioned, I finally got to look at the final now, so this is great. Would I say if it's easier or harder than my tests? Okay. Here's the thing. I think that the maybe the format and the questions that they're going to give overall might be easier than all the ones that I would give you on each test, right? And it's because it's more comprehensive, right? So they don't have, they can't just give you every single problem you could in the class, right? They kind of have to limit themselves. However, what I will say is there were some times when I would give you an example on a test, like a problem to do on the test, and it would probably be fairly a lot more like simpler examples that we might work out in class, right? So just as a quick example, right? If I had I might give something like, I would have given something like this in class, right? Where you had to find this limit. Okay. And for most of you would see, okay, well, it looks like I'll have the factor at the top. Okay. However, we might end up with something on the final that's not simply just let me factor the top and see. You might get something that looks like let me think real fast. I guess something that looks a little bit like this. Okay. Now, would you still know how to do this problem? Hopefully, I would like, but that's the goal, right? I would hope you still know how to do this sort of problem, right? Instead of just factoring the top, you also might have to factor the bottom and work things out, right? The thing is, the reason I emphasize this is because I think I've seen it's been a bit of a pattern, which I'm not completely blaming you guys for. I think that obviously it's just how things are sometimes. That we can see this and know how to do it, but then we get this and say, I have no idea. But it's the same problem. There's a little bit more you have to do to it, but it's ultimately the same thing, right? It's ultimately the same idea, right? If I try to plug in this number and it doesn't work, right, then I need to fix it somehow. I need to do something to it, right, to make it work, right? Here, it was pretty straightforward, just do the top. Here, I've had to put a little more work into it, okay? But in general, I don't think it's going to be too bad. Okay, let me sort of lay out what the big guys are in this case, though. Okay, so first, as already alluded to, you're going to need to know how to do limits. Okay. Right, so you need to go back and do a few examples of those, work through those, right? Especially kind of the two bigger ones we did, right? We did just like the one I showed and the one that's like limited as it goes through the thing, right? To work that out. Okay. So really need to know how to do this. Okay, that's the first thing. Let's see. Okay. Number 2. You need to know how to do your derivatives. Okay. So if you've really got your mind stuck in antiderivative mode right now, you need to try to make some room for the derivatives as well again, okay? And when I say this, I'm not just talking about chapter 2 derivatives, okay? I'm talking about derivatives from chapter 6 as well, right? So you need to know, right? Of course, you need things like product, quotient, and chain rule or general power rule, however you want to think about it. But we also need to be thinking about the trig functions, inverse trig, exponential, logarithms, and etc. Okay, you need to have those derivatives in your head to know how to do that, right? So if you have test 2, which most of you guys should have that back by now, you can look at that sheet to refer to everything. Okay, I would encourage you really to just try to remember the basic derivatives for each. I have on the back all of the ones with U in them, right? But that all can be grouped within this chain rule group, right? Which is what I've really been emphasizing. I want you to understand how to do chain rule, right? Because that's going to make things really nice. Okay. Okay. Also, let me add to this list. You know, remember how to do implicit derivatives. Okay. So that was when I had two sides of an equation. It wasn't just y equals something, right? I needed to figure out how to find the derivative of that. Okay. So implicit differentiation. Okay. First one, need to know. Okay. 3, this is something we haven't talked about in a little while. This is something that kind of comes with this, right? We need to know how to get tangent lines and normal line, right? So tangent line, if you remember, right, that's kind of how we define a derivative, right? The derivative gives you the slope of a tangent line at any point, right? So if I want to find, if I have a function and I want to figure out a tangent line at some given point, I use the derivative to get the slope, and that slope with the point gives me the line, right? So review over that, please look over that. We need to recall so that info. Okay. Optimization. Okay, again, this is another example of one where and most of you guys did pretty well, I think, on the easier example of this I gave on the test, right? It's not gonna be that simple. If you want a better idea of what the one on the test is gonna look like, refer to the other optimization one I gave on test 2. Right? So there was one where it was just like an area and perimeter of a box, and there was another one where it was like a volume. Okay, so really study that, really understand optimization well. Okay. Sorry to keep you over, but I think most of you guys want this information. So okay. Fine. So first derivative test. Okay, curve sketching. There's going to be a couple of problems that deal with this. Okay, so this is a big thing. Please really go back and look through the curve sketching. And I'm not just talking about on the test. I just give polynomials generally because that's the easiest way to do it. But there may not be one that's just a polynomial in the test. Now, if they give you one that's not a polynomial, they'll probably give you the derivatives, right, or that go with it, so you can easily plug in things and find stuff. But you need to know how curve sketching works. Okay, so that was chapter 3. So big chapter 3 stuff right here you need to have. Okay, because if you don't know that, you're going to lose 3 questions from the test for sure. Okay. So there's 11 questions on the test, but many of them have several words.
Just give it a number.
Yeah.
Question.
Yes.
You went down what chapters are with each section?
Okay. I'll mention, by the way, I would encourage you to look over four-step process, but I don't think there probably won't be any questions like that on the test. But it may be helpful to know. So this is this is really 2.5 to 2.9 and 6.2, 6.4. No, 6.2, 6.3, 6.5, 6.7, 6.8. Okay, maybe, I don't know, I would go over 2.6 maybe. That's those sections there. Here, this is kind of in junction of 2.8, but this kind of comes with those as well. So I would really tie this with a lot of those. Optimization was 3.4, curve sketching was 3.1, 3.2. Okay. Trying to speed it up here, 6. Know how to find integrals. Okay. You didn't know how to do this. This is primarily 4.3, 4.5. Actually, we skipped 4.6. And 4.7. Okay, which is improper integrals. Okay, so you need to know how to do all the regular integrals and you need to know how to do improper integrals as well. Okay, so we did that pretty recently, so I won't need to go into that too much. Okay, 7 kind of goes with this, but I'll write it anyway. Just to emphasize. You need to know this and you need to know this. Okay, and then this is 4.6. So that, again, this really could kind of go here, but this is what we need to know. Okay, it wouldn't hurt to review all the other things, of course, because everything kind of works together. But this is really what you need to know. Okay. If you're lacking in any of these subjects, there's going to be a good chunk of the test you're missing. So I wouldn't do that first. Okay. That helps. Yeah. Come back Wednesday. We'll have a easy quiz. I want you to look over stuff for it. Don't stress too much. Yeah.
That's like LED 100.
Yes. Lecture hall room 100 is where the final is going to be. 10:30. 12:30. On Saturday. Maybe I'll stick around a bit. I know some of you have to take a quiz with me, so.